Hello, it's Freddie Cruz, and I've made it my job to share with you the stories of the businesses, organizations, individuals, and that includes scientists that are making the greater Houston area great. And with 2024 predicted to be a peak year for auroras, I had to bring in a scientist to talk about the likelihood that we'll see an aurora here in H-Town. Her name is Dr. Sabina Stanley. She is the author of the book, What's Hidden Inside Planets. She joins the show to break down what auroras are, the likelihood that we will or will not see one here in Houston, and we also talk about really cool stuff like helium rain, life on other moons, and a bunch of other interplanetary awesomeness. Tap the link in the show notes to learn more about Dr. Stanley's work as a distinguished professor at Johns Hopkins University and as a scientist on the NASA Mars InSight mission. And if you enjoyed this episode as much as I enjoyed putting it together for you, please consider leaving a review on your favorite podcast platform and or sharing with your family members and friends. Thank you.
Hi, I'm Ed Sheeran. This is Bruno Mars.
Hey, it's Katy Perry.
This is your man Flo Rida with Freddie Cruz.
This is AJ Mitchell with Freddie Cruz.
Freddie Cruz.
Freddie Cruz.
Tell your Chico pick Mr. 305 and you already know what it is.
My name is Freddie, and it's time to cruise through HTX. Dr. Stanley, NASA in Houston calls you up in an hour from now, and they say we're sending you to space. What planet do you go to or moon, and why?
Oh, gosh, that's a great question. Okay, I think I go to Saturn. And here's why. Of all the planets in the solar system, I think Saturn has the most incredible view. So from just a pure tourist perspective, being able to go to Saturn and see those rings up close, I think would be absolutely fascinating. One of the most exciting things about the rings of Saturn is that waves actually form in the rings, and those waves are caused by motions happening deep inside Saturn itself. So we almost have this like telegraph system where the rings can tell you about the deep interior of Saturn. So I think I want to see that up close.
Okay, what you just said about the rings and below the surface of Saturn reminds me of something in the book that you talked about with the Northern Lights as it relates to a story you were talking about. It was the first time you saw them, and then you broke down in very layman's terms, and I respect that. I love that about the book. It's very approachable. But you talk about auroras and how it's essentially interplay between the sun, which is kind of far, and Earth's core, which is kind of deep. So what makes all of that possible? Again, explain this to me like I'm a 5-year-old boy.
Yeah, absolutely. So you take our magnetic field, right? It surrounds the planet. It's saving us from this horribly high energy particle stream that comes from the sun. And this entire magnetic field, even though it surrounds us, is actually created deep inside the Earth in the liquid iron core. So in the iron core, iron is a good electrical conductor. And if the iron moves around, turns out the iron core is liquid. And it can move around because it's convecting, which basically means, imagine you have a pot of soup on the stove. The bottom of the pot is hot, the top of the pot is cold, and so you're going to start getting buoyancy motions happen. So the stuff on the bottom's a little hotter, which makes it a little less dense, a little higher volume, it expands, and so then it can rise, right? Just like helium balloons rise in our atmosphere. So the expanding, rising, hotter material goes up to the surface, cools down, and then goes back down in your pot. Same thing happens in the core. So at the center of the core, the material is hotter, it gets expanded, becomes a little less dense, and it starts floating up. So you have these almost rolling motions happening in the core, and those rolling motions can create magnetic fields. And so the reason we have this beautiful magnetic field helping us, surrounding us here at the surface, is because of those rolling motions deep inside the core of the Earth, creating magnetic field.
And we get all this beautiful activity in the sky. And it's just like, how is this even possible?
Yeah, I love that so much, right? So this magnetic field is the one of the ingredients for the aurora. The other is you have to be hit by the solar wind. So the sun is spewing off these high energy particles. Some of them are electrons, for example, and those electrons have to spiral along magnetic field lines. They only get close to the planet near the poles where the magnetic field lines are kind of hitting into the planet. So you get close to the poles, the first thing you hit is the atmosphere. When you hit the atmosphere, the high energy electrons can kind of collide with atmospheric particles, and that causes them to jump up in energy and then get back down, and that releases photons of light. And those photons of light can be in very specific colors, which is why we get these beautiful colors in the sky.
Okay, so I'm piggybacking on this with a very elementary question. You talk about how this is what happens at the poles, and with 2024 predicted to be a peak year for auroras. Okay, here comes a stupid question. Because it's going to be a peak year, is there a possibility of somebody, let's say, here in Houston, Texas, maybe just maybe seeing something like that, even if it's with a really super strong telescope?
So not a stupid question, first of all. Here's the thing about peak activity, right? So when the sun has more sunspots, there seems to be a correlation between that and the sun having more solar flares.
Okay.
So there are these bursts of energy that come off of the sun. The sun sort of burps out a bunch of material. And that's where the solar wind comes from. So when we have more sunspots, we tend to have stronger solar wind. And sometimes when you get a really strong solar flare, you actually get it to be so strong that the shield, our shield here on Earth, the magnetic field, can't actually keep it at bay, right? So you're almost overcoming that shield. And when you do that, you can start having some of these electrons get closer to the surface and hit the atmosphere at places a little farther from the pole. So they can be more southerly here in the Northern Hemisphere. So will you see them in Houston? It's possible. There have been sightings of aurora much closer to the equator, for example, in the past when we had significant solar flares and what are called coronal mass ejections, so really big solar storms. It's happened in the past, so it's possible.
Okay. All right. I don't have to break into NASA either, which is also a huge help.
Absolutely.
Something you mentioned in passing, and it's something I want to talk about, is helium rain. I was today years old when I learned that that was such a thing. So can we talk about what it is, how it affects the universe? Do we have that here on planet Earth amongst us Earthlings? All the things.
Yeah, this is actually one of my favorite topics to talk about too. So I'm glad you asked this. So we are so used to certain materials behaving in certain ways here on the surface of the Earth, right? You take helium, for example, that's a gas. It's in our balloons that we float around, right? But when you start taking materials and say, put them inside a planet, the pressures get higher and higher the deeper you go. The temperatures get higher and higher the deeper you go. And materials can behave very differently when under those conditions. So helium rain happens because in Jupiter and Saturn, for example, those planets are mostly made of hydrogen. They're about 75% hydrogen and about 25% helium. And in the atmospheres of those planets, the stuff we see if you look at either Jupiter or Saturn through a telescope, in the atmospheres, those are gases like we're used to here on Earth. But as you go deeper and deeper inside those planets, the pressures get higher and higher. And the first thing that happens actually is that hydrogen becomes a metal. It gets squeezed so much that it basically becomes a metal. And when hydrogen does that, helium, which was nicely mixed in with the hydrogen above that, they were like best friends. They hung out all the time. When hydrogen becomes a metal, helium no longer wants to be mixed in with it. And so it separates out from the hydrogen. But then you compare hydrogen and helium. Helium weighs more. It's denser. And so the helium will actually fall relative to the hydrogen. And that's how you get helium rain. So essentially it's this like separation of the two materials from each other, and then the helium just drops out of the sky. So that happens in Saturn, very likely, and in Jupiter, probably.
How fun would it be to have helium rain here on the planet, here on Earth? I mean, we'd all be talking funny and, you know.
Absolutely. Yeah, weather would be much more interesting.
It really would be. Okay, so let's shift the conversation to plate tectonics and how Earth is the only planet in the solar system with these things, and it's what makes life possible, like human life and whatnot. Okay, so what planet is the closest thing to having plate tectonics? Can we, if we were to colonize another planet, create them on our own using our own ingenuity, or would that be like ill-advised?
Oh gosh, that's a tough one. So in terms of, let's start with the first one. In terms of the planet out there so none of the planets actually have plate tectonics.
Right.
But the closest analog out there is actually not a planet, it's a moon. So the moon Europa, which is a moon of Jupiter, looks from the surface like this beautiful icy ball. So it's mostly made of water. It's really cold out there in the outer solar system, so it's mostly ice on the surface. But at depth, about 10 miles or so down, we don't exactly know how far down, the temperature gets hot enough that the ice becomes water. It becomes liquid. So what you can picture for Europa is it's got this thick ice shell surrounding a liquid water ocean underneath. Now that ice shell, when we look at it, is actually broken into plates. Just like the Earth's surface, the rock on Earth's surface is broken into plates. And we actually have evidence, because you can look at images of Europa over time, we have evidence that those plates have moved around, and we've actually had one of the ice plates dive under another ice plate and disappear. And that's a very similar process as what happens on Earth at a subduction zone, where one of the plates will dive under another. So Europa is our best analog for plate tectonics, but it's in a completely different material. It's in water ice as opposed to rock.
Okay, now I'm curious about Europa. How cold does it get over there? Do we know?
It gets really cold. I mean, so when you have a body like Europa that doesn't have an atmosphere to regulate the temperature, for example, then the temperature can vary a lot depending on if you're facing the sun, for example, or not, right? But in terms of regular temperatures during the day or on averaged over the day, you're looking at something like minus 200 degrees Fahrenheit. So really, really cold.
Huh. Minus 200. That's child's play.
Hey, I'm Canadian. I'm used to cold temperatures, and that sounded cold to me. So
No, in all fairness, yes, you're absolutely right. You know, we lived up in Minnesota for 3 years, and I remember a wind chill advisory of minus 65, and even the dog was like, no, I'm going to be a camel today.
Yep.
I don't need to go
We have limits.
Yeah. Oh, goodness. Okay, so building on moons, and there's Europa. And you write in your book that moons are not all that different from planets. It's something I've never really considered because, well, the moon is a moon, and that's what we call it. But you say they're not that different. So why are they, and why do we still consider them moons instead of planets?
Yeah, great question. The only difference between a moon and a planet is what it's orbiting, right? The planets orbit around the sun, moons orbit around planets. So from an orbit perspective, they are different. But if you're thinking about what goes on their surfaces or what goes on in their interiors, then there's no major difference in the processes or anything when we talk about planets or moons. So the important thing is there are lots of really cool planetary bodies that include planets, moons, dwarf planets, comets, asteroids. There's lots of cool stuff in the solar system, and we can go to all of them and look at all of them in order to understand, for example, how Earth works. We're not limited by just looking at the planets.
It seems to me like because we've only ever been to the moon, right? It seems to me like moons might be more inhabitable for humans. Seems like our chances for survival would be better on a moon or something similar to maybe Europa, as long as we like quadruple layer and stay inside the whole time.
Yeah, absolutely. This is the fascinating thing about our solar system. If you were to ask the question, what other objects in our solar system have some of the ingredients that we think are important for life? Most of the ones we come up with are actually moons, not planets. So for example, if you want to think about where is there liquid water in the solar system, where are there liquid water in contact with rock, where are there complex carbon-based molecules that can get nice, cool chemistry going? And the answers to that are moons like Europa, Saturnian moons like Titan and Enceladus, they all have these ingredients. And so a lot of the discovery or exploration that we're aiming for in the future are actually to go to these moons because they seem to have some of the best possibilities for life to have formed there, or at least have the ingredients for life to form there.
Okay, what about asteroids?
Asteroids are amazing.
Yeah. Okay, so I've read somewhere, I know you can't believe everything you see on the internet, although I want to say that I read this in a couple of spots that were not just like fake news sites. They've got gold.
So asteroids, what you want to think about asteroids is that they're basically the leftovers of the ingredients that created the planets. So for example, we know that there's gold in the Earth, right? We get it here on Earth. So it's not surprising that there's also gold in asteroids. It's not that there's like a gold nugget asteroid out there that's entirely made of gold, but the rocks in the asteroids are going to have similar compositions to the Earth. So you are going to find rocks that have precious metals like gold, other metals that we can use, but they'll probably be in similar fractions to what we find here on Earth.
Okay, in terms of, let's just say for our very survival, if there was a nefarious group of individuals on the planet who wanted to go and mine an asteroid for its resources, for better or worse, how possible would it be to do such a thing? Like, are they just so unstable because they're leftovers and they're not rotating around a sun or a planet? So
here's the surprising news. It's very possible, and there are companies out there planning to do just that. So lots of missions, for example, not lots, but there have been missions that have tried to, for example, land on asteroids, because it would kind of important to land on the asteroid before you can try to get resources from it. And we've found that is possible. We've figured out ways to do that. And there are some mining companies, resource companies that are looking into, hey, are there some near-Earth asteroids? Could we develop technology to go and mine them in an economically feasible way, right? Right now, the problem is it would be way too expensive. You wouldn't get what you want from it. But in the future, with new technology, sure, it's possible.
Okay, one last question. I'm sorry, I have two more. Why does, and I meant to ask this at the very beginning, why does Venus annoy you?
Venus is the worst planet. Let me just put that right out there. It's the worst. And I mean, really, Venus is a lovely planet. But if you're someone like me who tries to understand what is happening inside planets, Venus is just like, yeah, go figure out these really cool techniques to study the inside of planets. It's not going to work here. Too bad. So every single way that we have figured out to study the insides of planets just fails when you try to do it at Venus. I'll give you a couple examples. So one way we can actually figure out what goes on inside planets is by looking at how bulgy they are from their rotation. So all planets spin. That's why we have a day on Earth. And when you spin faster, you get kind of fatter at the equator than you do at the poles. So the Earth is a little bit more football shaped than sphere shaped. And how much fatter you are at the equator.
Okay, I'm sorry to interrupt. You said Earth is more football shaped than sphere shaped?
That is correct. So it is wider at the equator than it is at the poles. So if you were to walk around the equator, you would walk much longer than if you were to walk from the North Pole to the South Pole all the way around.
Okay.
So it's a little bit. It's not extreme, right? It's a small bulginess, but it's there. Okay, and how bulgy a planet gets based on its spin can be used to infer what the composition is like inside. So where the mass is distributed. So you do this. We do this for all the planets, except for Venus, because Venus rotates so slowly that it basically has no bulge. So we can't do that. And then you're like, well, how else have we learned about things on Earth? Seismology has been fantastic on Earth. So we use, whenever there's an earthquake on Earth, waves travel through the planet. The speed of those seismic waves are completely related to what material they're going through. So we can use detection of waves arriving all over the surface of the Earth to kind of image the inside of the Earth. So like, okay, let's do this at Venus. Oh, I'm sorry. The surface of Venus is hundreds of degrees in temperature. The atmosphere is corrosive, and any instrument you put down there is going to basically melt within a few minutes. So it's impossible for us to put seismometers on the surface of Venus to do that as well. And it goes on and on. Every method we come up with, Venus is like, no, I'm not interested. So it's a very annoying planet.
Just cooperate already. That's all we're asking.
Exactly. We just want to learn. We just want to learn what you're made of.
What's Hidden Inside Planets? It's by Dr. Sabina Stanley. And y'all, get this book. It is if you've ever wondered more about not just Earth, but what is actually going on outside this spinning rock that rotates around this thing we call the sun, this is a great book to get some insight and learn about some of the things that are happening beyond what we see and experience in our daily lives. And you realize just how vast the universe really is. It's so cool. So thank you for coming by the show. And I want to end the conversation with something you wrote that I loved. You're the first person I've ever talked to who has a favorite Japanese haiku from a long time ago. And it's this: in this world we walk on the roof of hell, gazing on flowers. What does that mean to you?
Yeah, thanks so much for bringing that up. So I love the image of that, we sit here walking around our daily lives here and we have no idea of the immense forces, the fierceness of everything that goes on below our feet. And we just kind of sit here on the surface doing our own thing, not in any way kind of terrified at all this amazing stuff that's happening below us. So that's what that haiku means to me.
Thank you so much for joining the show, Dr. Stanley.
Thank you. This has been great.
Hey, it's me. I'm back with a quick little nudge. If you enjoyed this podcast as much as I did putting it together for you, then please leave a review on your favorite podcast platform and subscribe to the newsletter at cruisethroughhtx.com and share with your family and friends. Thank you.